Now that we have our fitted data, we can do now easily mathematical diverizations of these lines. Right? So, for example, now that we have this shear stress versus shear rate data, we know that from our online lessons that if we take the derivative of this data, we get the viscosity function. So let's go ahead and do that and show how we can set this up to show both the shear stress and viscosity as a function of shear rate. Again, go ahead and just select this line, double click on it. Okay, so now that it's selected, we can go ahead and fit this, or go ahead and do a derivatization directly on it. So we go back up to analysis. And this time we're doing mathematics on it. So go down to differentiate and go to open dialog. Alright, so here we can see all the parameters that go in it. And in this case, you can do a number of derivatives. If you want to do a second, third, fourth on, you can do it. But for our case, we just need a first order derivatives. We don't need any smoothing or output. And the output is essentially going to be put directly into our data sheet. So we'll go ahead and press OK. Now, if we go down to our data sheet, right? So this goes back to our 300 volt, right? So this is our 300 volt, and we look now into the fit curve there. Again, we can make this a little larger. Bring this up. You can see in these two new columns that our derivative data has been put inside there. So this was our original fitting data, and you can see that our fitted data is over here, right? And now let's take that fitted data, it's done the derivative on it, and it's put that over here and labeled it into its own independent data x1 and y1. So now we know where that data is. So this is important. So we got to kind of look at where these rows are, this L and M of this fit linear curve 1 for this elementary 2 fit. Okay, so now let's go ahead and quickly do the other lines. Just select them. Go to our analysis. And again, we can just do the differentiate last used. Very quick. Okay. And now we can see that data has been updated in this fit linear curve 2. Our last line. Analysis. Differentiate last used. Press OK. Okay. So very simple. The mathematical operation is done. The data is put into our worksheets. Now what we want to do is put this data directly into our graph to show essentially a dual axis, a dual y1 and a dual y2. To set that up, we need to tell this graph that we need another layer. So in this case, what we want to set up is another y2 layer on the right side. So if you go over on the very right, over here on this graph bar, you can see that we can add a number of different layers and in a number of different ways. So we want to use a right y layer that's going to use the same x-axis. So that's why we're going to do this. If you wanted to use a different x-axis, you could. And this one puts on the right y layer and then puts an x2 on the top. So there's a number of different options you could do. So we're going to click on this one, just add right y layer. Click there. And now you can see our new y2 axis is here. And you can see up here that this data now is in this, we need to add data into this second layer. So if we just click on that, then comes up the layer contents. And this is where we can choose to put in, expand this out here a little bit. This is where we can choose to put in this data. Okay. So you gotta scroll a little bit. Okay. So right now, our layer 2 is blank. So we have to choose what data we tell the computer what data to put inside there. Okay. So we can see that already that it's actually kind of pre-labeled. That here we can see that we have this 300 volt data here. This is the first one. And if we put in this derivative y1, click on it, and click the arrow and say add plot. Okay. So that's the 300 volt one. If we scroll down, we can get the other ones. Okay. So this is the 150 volt one. And this is the 0 volt one. And we add that. So now the three derivatives, or the viscosity functions, have been added to the plot. We'll go ahead and press OK. And you can see they've been added here. So now we have to go ahead and make this look interesting. So anybody who views our data can easily discern it. So as it's done this, it's kind of replotted this too. So we have to go back and put in these correct values. Okay. So the first thing we can do is update our y2 axis with the correct information. So we'll click on that. We know that this is the viscosity function. And by now you should know that the units are Pascal seconds. Okay. Then again, make these nice and easy to read. And then our right y-axis, we don't need to scale it yet, it's okay. Click on it, and we want to make this at least 28 font. We can go and fine-tune this later if we want to change this. I'm going to change our x-axis. I don't like this type of spacing here. Click on it. A dialog will show up. So go ahead, we can click on scale. As before, we're going to put it to negative 0.2. 2.2. Usually you want to do about 10% less and 10% greater than your two data plots. And then I'm going to increment it by, let's say, 0.5. Let's see how that looks. That looks okay for me. Let's take a look at the vertical axis. That looks fine. So right now we're doing everything on layer 1. If we go down to the lower left here, we can see that we can change this to layer 2. So then we can change the axes there. Okay, so the vertical, to me, there's a little too many lines for my liking there, so I'm going to change this to, let's say, 4. And press apply. And it makes an update. So we can go ahead and close this dialog, press OK. Okay. So now we have to make sure our lines are looking nice as well. So we'll start with our 0 volt here, our 0 volt viscosity. Double click on that. It automatically highlights it. So we want to make it essentially readable with respect to our shear stress lines. So we'll go over here. We still want this that's aligned with the 4. And we're going to make it the same color. Press apply. Okay. But we have to make sure to differentiate this so people understand that one line is shear stress and the other one is viscosity. So for that, we can just change the style. So I'm going to put in a dash. There's other methods to do this. You can put it with symbols. That would be okay as well. Now let's go do our other data. do the same thing. In this case, it's going to be green. And we also make this a dash. And we press OK. Oops, sorry, press apply. That's updated. Our last line, our 300 volts. It's red. And also a dash. Press apply. Okay. That's it. So now that we have very good, almost professional graph here looking, but we have to make sure that the readers know the difference between what's the dash and what viscosity plot is. So there's a number of ways we could do that. We could set up a line here and just put say line. We could set up into your dash. So for simplicity, what we'll do here is just write in line. And viscosity, we'll double click on that and write in dash. Okay. Now we have a very professional looking graph. Right? Shows our shear stress versus our shear rate, shows our viscosity versus the shear rate, and people can easily see what's going on in terms of this Bingham plastic, this chocolate, as it's applied now to voltage. So you can start thinking yourself, so, okay, what is actually happening here as we apply from 0 volts to 150 volts to 300 volts? What is actually happening here with respect to the viscosity? So now, there's a number of ways you could do this. So if you wanted, you could just do Control-C, copy and paste this to other programs. But if you want to put this professionally, you want to make sure that you have a very good export photo in TIFF or JPEG. So I'll give a quick demonstration of how to do this now to make your reports later. So if you go up here to File, and then to Export Graphs, click on Open Dialog. Now I'm going to give you some pointers about what my go-to method is. So I have a default method I've set up. I always make it TIFF files because I know I can change TIFF files into anything. I select the graph. I said, okay, I only want to work with the active page, nothing else. But if you wanted, you could select all folders and do this in a batch process, or all graphs that you have. This is just the active. I'm going to do just a long name. So essentially the name that I already give it, in this case it's graph, it's going to just put that in file we save as graph 1. Okay. And it's going to automatically direct it to the path of the project folder that my OriginPro is saved in. And remember to save OriginPro often. It does tend to crash quite a bit. Okay, so in terms of image size, right, I pick a very standard width. Right, so I know this will work pretty well for all for my PowerPoint and most manuscripts as well. Essentially, you're making it about the width of a page that you can then reduce down later. This is very important. Always make sure you have pretty good DPI resolution. So for anything that's going to go into manuscript, you need at least 300 DPI. You can make it larger, but that's just going to increase your file size, and then you don't necessarily get any better resolution out of that, or any better photo quality out of it. Depending if it's going to be shown on the web, it should be RGB. If it's actually going to go to print, it's going to be CMYK. So this kind of depends on certain publishers. Most of the time I just leave it RGB. Most manuscripts are read online today anyway. And to keep the color profile down, I usually choose either 256 or 16 colors. You don't necessarily need to go higher unless you're doing grayscale. Then in that case, you go to 8-bit grayscale. And this is especially important for different, especially if they're going to be printing it out and you know that they're not going to be printing in color. Okay. And this just gives it a bit of compression. It's not really needed, but I put it in this LED. And then from there, you can actually hit the preview. Okay. and then it gives you an idea exactly what it's going to look like as the output, which looks pretty good, nice and professional. You can press OK, and then that TIFF file is now output and ready for you to include in your manuscripts or PowerPoint.